We try. I do not have too much things to talk at this time because most of the discussions about lighting location system have already been done by most of the people that are involved on the CHUVA campaign. So I'm going to focus on the BRASILDAT network because most of you does not know about this new network that we have deployed in Brazil. And the original title of this presentation was Comparative Analysis of BRASILDAT Total Light Network for the Paraíba Vale, or Vale do Paraíba CHUVA Campaign. I take out the Vale do Paraíba because the analysis was done for a large area, not only the Vale do Paraíba. And just to let you know some facts about the network. So the BRASILDAT is a total lighting network because it detects both cloud-to-ground and intra-cloud flashes using the time of arrival technique. So you need the GPS synchronization of most of the systems do that. And this is a wideband sensor. What means a wideband sensor? The sensor detects a wider frequencies from 1 Hertz. So it means that the sensor can operate on the VLF range to 12 megahertz. It's not VHF, but it's very high frequency on the LF range. So this is a VLF, LF extended sensor. So we can have very good information about the waveforms. Since the sensor detects all the waveforms and send them to the central processing, we have a very good opportunity to study lightning in a large scale. So we can have the waveforms for all the events, every detection that we have from the sensors, and individual sensors, we have a waveform of the signal that they receive. So it's a very useful for lightning research to have this information. And of course that having the whole waveforms, we can study not only the particular of lighting physics, but we can improve the way to discriminate cloud-to-ground and intra-cloud flashes. Today is the most important challenge on lighting location system is to better or to discriminate between intra-cloud flashes and cloud-to-ground flashes. So it's a subject that's been studying for many years, and there's many efforts of Vale for F networks, and all the people that works with lighting location system try to find a better way to discriminate between cloud-to-ground flashes and intra-cloud flashes. And you have seen this morning many different ways to detect them. So at this time, BRASILDAT has 56 operational sensors in Brazil. That's the map on the left panel. So you see that most of south of Brazil is already covered by the network. So from Rio Grande do Sul here, I have a pointer here. Yeah, from Rio Grande do Sul here to Bahia, Goiás, Mato Grosso do Sul, we have only one sensor in Mato Grosso. We have coverage from the BRASILDAT. The mean baseline is around 300 kilometers, 300 and a half. So now we are extending the network to the northeast of Brazil. In the next months, maybe 2 or 3 months, we are going to start the installation of more 15 or 16, I'm not sure exactly the number, but we are going to extend the network to the northeast Brazil. We are going to reach Maranhão. And for the CHUVA campaign, we have installed 5 additional sensors that we are using for the solutions in the area of the CHUVA campaign in São Paulo and Vale do Paraíba. So the location of these 5 sensors are exactly the same of the LINET network. They are exactly co-located in the same site. And thus the network provides the solutions using all the sensors, not only these 5 sensors here. Why? Because the time of the campaign, we are still deploying the network. So at this time, we do not have a CPMS that we call the central processing of the Earth network system. We, at that time, did not have the CPMS in Brazil. The CPMS was deployed this year. We have the system installed in the last 2 months. They start deploying that on February and they finish on April. So we are now running the CPMS and we have control of all the sensors here in Brazil. And that time we are deploying and calibrating and validate the system. So there are some points that I have to talk to you about the BRASILDAT data that you have in the CHUVA dataset. So this is the area, the official area of the CHUVA campaign. So all of the data that is provided for lighting location system should be within this area, but we have checked that they are not. Some of them are in the circle, some of them are in the square. There are some larger areas and smaller areas, so no, that's not a problem. It's only a comment about the data sets that we have. And we have done previously some evaluation of the BRASILDAT in southeastern Brazil. This is not related to the CHUVA. This is separate. This is a different work that we have done, trying to first evaluate the detection efficiency and location accuracy of the network. I am not going to the details, but this is high-speed cameras, videos from the Hammer project, that's from Antonio Saraiva project. And we have compared the CG flashes recorded by and the strokes and flashes recorded by the videos and by BRASILDAT. This is very important because BRASILDAT network does not provide flash information. All the information that from BRASILDAT, from the Earth network system, are strokes, not flashes. So if you want to have flashes, you have to group using kind of algorithm. And Vaisala has their own algorithm to group flashes. So we have found these numbers with videos comparisons, and the detection efficiency as a function of the stroke order. You can see from the first strokes orders, they have a very good performance at that region. If you look at the location accuracy evaluation, we have done this only for 16 upward lighting. This is the Marcelo Saba project. Marcelo is going to have a talk in the next talks here. He's going to tell about more details about upwarding. I'm not going into the details. But from the 16 upward lightings, the BRASILDAT have detected 14. And for 10 events, the location area is lower than 400 meters. And sometimes you have lot less than 200 meters. So for a large baseline network, this is a very good performance for location accuracy. And it's important to to tell you that the upward lightning events can present usual waveforms. Because remember that the upward, and Marcelo Sab is going to tell more details, upward lightning has different waveforms because they are more similar to subsequent strokes, and they have continuous currents, reconnection, recoils, some different pulses on the waveforms. So sometimes you have very different waveforms for the upward lightning. So, and the peak current evaluation, that's what I have told this morning. We have compared the BRASILDAT with the RINDAT. The RINDAT network is the Vaisala system that we have in Brazil. The Vaisala system have now 35 sensors. There's a hybrid network. We have sensors of all generations. I would like to offer Vaisala to have a museum here in Brazil, because we have all the sensors since the beginning, from Series 3 through LS 7000. So we have sensors for all the generations of Vaisala, and we are now working to upgrade the system to have a better network using the new Vaisala technology from LS 7000 and even TLS if possible. But we are now working to get this network back on to new sensors. But even with these old sensors, the peak current estimation for RINDAT is reliable, and we have saw that the BRASILDAT has an offset of on the peak current estimation for the data that you have in the CHUVA dataset. So the BRASILDAT peak currents are lower than the effectivity are, and this might be the suggestion of the correction that you have done. This is for negative and this is for positive cloud-to-ground flashes. If you want to correct to get the data more related to the Vaisala system, that's our reference for peak current, we have to correct this data. Of course, the RINDAT system is not a ground truth, but it's the best estimation that we have right now. Now we are working to get the sensors calibrated, the LS 7000, so it might change this information from RINDAT and get better. And this is the plot, ready now, 2 minutes? And this is the plot of the RINDAT compared to the BRASILDAT, so you can see very well that the BRASILDAT is detecting lower, the peak current estimations are lower than the effective they are. So I'm not going to get into the details of all these numbers here, but this is the numbers that we have found for the data sets in the CHUVA campaign. I'm not going to the details. We have done analysis for February and March. That's where we have most of the sensors operational, more thunderstorms. But I would like to tell about the peak current here. So you can see the comparison of all BRASILDAT to different networks that provides the peak current information. So the GLD, the TLS 2000, only the LF portion, because we are looking only for cloud-to-ground flashes. And you can see that in all cases, except from the LINET, this is intra-cloud flashes. The intra-cloud flashes from LINET and BRASILDAT, they show exactly the same. This is because peak current for intra-cloud has all the limitations that we know, but looking at the CGs, you can see that LINET, the GLD, and TLS have almost the same distribution, and the BRASILDAT has a lower peak current values. So we tried to compare the data from BRASILDAT to the LMA, but the LMA has the bands, the noise that we have discussed before. We need to decide which kind of noise reduction technique we are going to use, but taking away all the noise, we can see that the BRASILDAT, the intra-cloud and cloud-to-ground flashes match very well with the LMA. In most of the cases, this is February 7th. And this is February 21st, where we have a very large, a lot of thunderstorms in the Chuva area, and the BRASILDAT nets very well all the thunderstorms, the particular cells that we have here. And here we do not have any lighting detected by the network, but we have a lot of solutions. Finish? Okay. So at this time, this is the last slide. You can see here there is solutions, but you have nothing in this day. This is all noise from the LMA. So this is a very important thing. So we are planning to reprocess. Now we have the CPMS from BRASILDAT here in Brazil. We are planning to, this is to show the differences in events and the noise that appears on the high distribution. Most of the lighting is on 1,000 meters. That is the noise that you have in LMA. There's no correlation with the cloud-to-ground flashes and the intra-cloud flashes. And now we are going to reprocess all the BRASILDAT data sets to correct the peak current and to include the microsecond information. Because if you look to the BRASILDAT data, at that time, we are not providing microseconds. We are only providing milliseconds. So it's very hard to compare any kind of light detection network only with milliseconds data solutions. So that's it. Thank you very much, and we are open for discussions on the round table.
Questions? Ken?
Oh, sorry. I'm sorry. I'm so loud. Oh, yes, okay. Make sure they're awake and still. So what you just said a minute ago about providing the BRASILDAT data in millisecond timing, but
Microsecond. Or nanosecond.
Oh, nanos. Okay.
Nanosecond.
I thought you just said millisecond.
No, it's nanosecond because sleeping. Now we have only millisecond. Yeah. For the solutions of BRASILDAT, on the data, you have only milliseconds. You don't have the nanosecond.
I see.
Do you have any information whether it's the lower frequency part of the spectrum that's finding the location of your source or your strokes or whatever it is, the lighting event, or is the high frequency?
Is for the intra-cloud?
I don't know. So can you differentiate because you're measuring waveforms?
Yeah.
Which one do you use the solution?
Usually the high variation, the high frequencies are related to to get detection of intra-cloud. And what they do is correlate in time all the waveforms that they're detected by the sensor. They have the same waveforms. And once you have high frequency, you can have a better better picture of the waveform. There's no analysis on frequency, particularly on that kind of frequency.
I have a question. Well, you can do it first.
Just a comment about detection efficiency and frequency range. At a frequency of around 400 hertz, if you convert that into the time scale, you get, a time waveform with a duration of about 3 microseconds, let's say, and 400 kilohertz. And for the distribution of total durations for lightning pulses, especially cloud lightning pulses, which tend to be narrower, it is generally seen that the median value is close to 4.5 to 5 microseconds, including all those sub-microsecond scale pulses that can occur. So the effect of, as your last portion was that, you know, the effect on detection efficiency for, you know, the higher end of the frequency spectrum is not expected to be enormous. And I do agree that probably for wave shapes, for waveforms that are a microsecond or smaller, the wave shapes might be distorted if you're limiting the frequency bandwidth. However, the detectability of the signal itself, given that the median duration is expected to be about 5 microseconds, shouldn't be affected. So that's, you know, that's one part of the concept. And also, as far as the classification of lightning goes, if you have waveforms at the higher end of the frequency scale, we are looking at total durations of 1 or 2 or 3 microseconds. And generally, cloud-to-ground lightning discharges wouldn't have total durations of 1, 2, 3, 4 microseconds. So it's, yeah, I mean, we probably need to understand better what the effect of the higher frequency content of the signal is on both detection efficiency and classification.
Unfortunately, Stan is not here. Stan is the... Yeah, it's always. And Stan is working on the details of this. I'm still learning about this kind of technology. I have been working with the Vale system many years, and this is very new for me too. And I have some questions about this, and we are discussing on how this can help us in this kind of. But what I have saw is that it works well in some kind of, in most of the situations that works well. But of course, we have some limitations in any case. You don't have any question?
I do, but I will leave for the round table.
Okay, thank you. Thank you very much.